Tiende pamozi ni mtima umo. 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 Tiende pamozi ni mtima.
Hello viewers, and welcome to MTN Teleschool. My name's Mutakela Ingotu. I'm pleased to be on this platform where I get to have an opportunity to revise with you 2019 School Certificate Science Paper 2 Chemistry. So sit back, relax, and enjoy the revision lesson. As you all know, chemistry, which is Science Paper 2, comes in 3 sections. There's section A, which consists of 20 questions, and then there's section B, which is structure questions, which consists of about 9 to 10 questions. Then we have section C, where there are 3 questions, and on these 3 questions, you have to choose 2 questions. So we start with section A. Section A, compulsory. Answer all the questions on the answer grid provided. Question 1. Which of the following is an example of the application of chemistry in a home? We have 4 options there. The use of amplifiers in a radio, the use of cosmetic, production of ammonia in the Haber process, industrial production of alcohol. The correct answer is B. When we talk about home, we can't talk about production of alcohol or production of ammonia or use of amplifier in a radio. So the correct answer is B, which is the use of cosmetics. Question 2. The best apparatus that is used to accurately measure a required fixed volume of a reagent during titration is, so we have a beaker there. The first option is a beaker. The second option is a pipette. The third option is a measuring cylinder. And the last option is a burette. Now, during titration, we use a pipette and a burette. The instrument which is used to measure accurately the volume, the fixed volume of a solution is a pipette. So the correct option is B. Question 3. The best method to separate a mixture of sand and diesel is, the best method to separate a mixture of sand and diesel is A, decantation, B, distillation, C, evaporation, D, filtration. We cannot use decantation there. Why? Because we still have a mixture of diesel and sand once we try to remove the diesel from the mixture. Distillation is not possible. Evaporation is also not possible. So the correct answer there for us is D, which is filtration. Question 4. Identify an inert gas from the diagram below. So we have the diagram of different types of gases there. We have A, B, C, and D. So the correct option there is, that is question 4, is C. When you look at A looks like it's a molecule. Then B looks like it's a mixture of different gases there. D also looks like it's a molecule. But C, it looks like it's an inert gas which is made up of one element. Question 5. The following equation is incomplete. What is X? So for us to find X, we need to complete the equation. So lithium hydroxide reacts with hydrochloric, not hydrochloric acid, but sulfuric acid. When that reaction takes place, what is going to be produced is lithium sulfate plus water. What we have here is a very good example of neutralization reaction, where a base reacts with an acid to produce a salt and water. The salt that is produced is lithium sulfate. So substance X is lithium sulfate with this formula Li2SO4 plus H2O. So looking at the options which are given here, when we try to balance the first thing is we balance the equation. So we'll put a 2 here and a 2 there. So by doing that, the equation is balanced. So after balancing the equation, we look at what we have on the product side, which matches with the options which we are given there. So the correct option there is A, which is lithium sulfate plus water. Question 6. Which of the following molecules has a triple bond? Which of the following molecules has a triple bond? The first one is chlorine. Chlorine has a single bond, as you can see. That is chlorine molecule. So that in the outermost shell of each chlorine atom, there are 7 electrons. So each chlorine atom has 7 electrons in the outermost shell. So these 2 atoms are going to contribute 1 atom each to the sharing of electrons in the covalent bond. So since each atom will contribute 1 electron, we call that a single covalent bond. The second one is carbon dioxide. Carbon dioxide is made up of 3 elements, carbon and oxygen. We have 1 atom of carbon and 2 atoms of oxygen. So the bond is going to look like this. So this is carbon, then we have oxygen, 2 atoms of oxygen and 1 atom of carbon. Carbon has 4 electrons in the outermost shell. So 2 electrons will come on the other side where it's sharing with the other oxygen, the second oxygen, and the other electrons will be on the other side where there's another oxygen atom. Oxygen has 6 electrons in the outermost shell. So we are going to have 2 electrons outside the intersection. Then this also 1, 2, sorry. So each oxygen atom is going to contribute 2 electrons to the covalent bonding. So this is carbon dioxide. So this is not a single or triple bond, but a double bond. Why? Because each atom is going to bring 2 electrons which are going to be shared in the covalent bond. Then when we look at the third one, which is C, which is the nitrogen molecule. This is nitrogen molecule. Nitrogen has an atomic number of 7 and it has 5 electrons in the outermost shell. So the first nitrogen and the second nitrogen, The first nitrogen will bring 3 electrons to the sharing, and the second one will also bring 3 electrons to the sharing in the covalent bond, leaving 2 outside. By doing that, it has acquired an outermost shell which is fully filled with electrons. It is sharing 6 electrons plus the 2 outside. Then, this is what we call a triple covalent bond. Why? Because each nitrogen atom is bringing 3 electrons to the covalent bond. The last one is oxygen atom. By looking at the options which we already have, we already know, we don't even need to go to the last one. Why? Because we already know that the one with a triple covalent bond is the nitrogen. So our correct answer there is C. 7. The equation below shows the preparation of salt. Silver nitrate plus sodium chloride will give us silver chloride plus sodium nitrate. Which of the following gives the correct description of the equation? We have the salt, type of salt, method of separation. A, silver chloride insoluble salts, which is correct. Method of separation, filtration, which is also correct. Then we come to B, sodium nitrate, soluble salts, correct. Method of separation, decantation, wrong. Then we have silver chloride, soluble salt, no. Silver chloride is not a soluble salt but an insoluble salt. Method of separation, crystallization, which is also correct. Silver chloride is not separated by crystallization, and it's not a soluble salt. But if it was a soluble salt, yes, crystallization was going to be okay. Sodium nitrate, type of salt, insoluble, not correct. Filtration, method of separation, filtration, which is also not correct. Yes, insoluble salts are separated using filtration, but sodium nitrate itself is not an insoluble salt. So the correct answer for question 7 is A. Silver chloride, which is an insoluble salt, is separated using filtration method. What mass of copper 2 oxide would react completely with 5 centimeters cubed of a 0.5 molarity dilute sulfuric acid? So when you look at the question, you've been asked to find the mass of copper 2 oxide that would react completely with 500 centimeters cubed of a 0.5 molarity dilute sulfuric acid. So we are looking for mass, but what have we been given? Let's take our data. We've been given the volume, which is equal to 500 centimeters cubed. What else have we been given? We have concentration, which is equal to 0.5 molarity, okay? So molarity, that is concentration. So how can we define concentration? Concentration is defined as the amount of solute dissolved in a unit volume of a solution. And the unit for concentration are given as mole per decimeter cubed. So concentration, which is expressed in mole per decimeter cubed, is called molarity. So molarity is the number of moles of solute in 1 liter of a solution. So in other words, we can say molarity is equal to number of moles over volume. But before we come to this, for now, let's look at what we've been given and see how we can find the answer. The question is asking us to find the mass, but we cannot find the mass without knowing the number of moles. So for us to find the number of moles, we use the formula, which is here. Molarity is equal to number of moles over volume. Since we have molarity and we also have volume. So in this case, what we do is we make N the subject of the formula. So N is equal to capital letter M multiplied by V. So M in this case, where M is equal to molarity measured in mole per decimeter cubed. The units are mole per decimeter cubed. Okay? Then we have number of moles, which we don't have there, which is moles, and the units are moles. Then V is equal to volume measured in decimeter cubed. From what we've been given here, from what we know, M is equal to concentration. So which is also equal to 0.5. Then we make N the subject of the formula by multiplying M and V. So in this case, we are going to have M 0.5 molarity multiplied by V, which is 500 centimeters cubed. But bear in mind that the volume which we've been given is given in centimeter cubed. It's not supposed to be in centimeters cubed, but it's supposed to be in decimeters cubed. And therefore, we need to convert 500 centimeters cubed to decimeter cubed. So 1 decimeter cubed is equivalent to 1,000 centimeters cubed. X is equal to 500 centimeters cubed. Then we make X the subject of the formula. So X is equal to 1 decimeter cubed multiplied by 500 centimeters cubed divided by 1,000 centimeters cubed. Centimeter and centimeter will cancel. When you divide that, we are going to have 0.5 decimeter cubed. That will be our volume. So 0.5 molarity multiplied by 0.5 decimeter cubed. So we convert the molarity to the actual units which are equivalent to mole per decimeter cubed. So this will be equal to 0.5 mole per decimeter cubed multiplied by 0.5 decimeter cubed. Then decimeter cubed and decimeter cubed will cancel. When you multiply that, 0.5 multiplied by 0.5, our answer is going to be 0.25. So 0.25 will be the number of moles. But this is not our final answer. The question is asking us to find the mass of copper 2 oxide. So therefore, we use the formula number of moles is equal to mass over molar mass. And we are not looking for number of moles. Here we are looking for the mass of copper 2 sulfate. And therefore, we need to make M the subject of the formula. So therefore, M will be equal to N multiplied by MM, where N is equal to the number of moles then MM will be equal to the molar mass of copper 2 sulfate. Okay, so our N, we've already calculated our N, and this is equal to 0.25 moles multiplied by the molar mass. Molar mass of copper 2 sulfate. Before we put down our molar mass there, we need to calculate the molar mass of copper 2 sulfate. And for us to do that, we need to come up with a formula for copper 2 oxide. Copper 2 oxide, sorry. This is copper 2 oxide. So copper 2 oxide, copper is represented by the symbols capital letter U, capital letter C, and small letter u. And oxide, that is oxygen, represented by the letter capital letter O. The valence for copper in this case is 2, and the valence for oxygen is also 2. That's the more reason why we have 2 in brackets, telling us that the valence that we are going to use for copper in this case is 2. So we interchange the valences, so we are going to have copper 2O2 oxide. Then these valences can easily divide, and therefore we find a number that can go into 2 and 2 without leaving a remainder, and that number is 2 itself. So 2 here, 1, 2 there, 1. So our final formula will be that. After finding our formula, then we find the molar mass of copper 2 sulfate. So the molar mass will be copper oxide. Then we list the elements that are found in copper oxide, that is copper itself and oxygen. How many atoms of copper do we have? 1, multiplied by the mass number of copper from the periodic table, that is 64. Then how many atoms of oxygen do we have? 1, multiplied by the mass number of oxygen taken from the periodic table, that is 16. This is going to give us 64. And this will give us 16. When we add this, we are going to get 80. Okay? So then we bring our molar mass there, which is 80 gram per mole. So more and more will cancel. Then we multiply that. When we multiply that, we are going to get 20 grams. Then we look at the options which have been given there. Which one gives us 20 grams? That is option D. So option D is our correct answer. Question 9. The table below shows some transition elements and their uses. Which one is the correct use in the contact and Haber process? So we talk about the transition elements which are used in the contact and Haber process. Haber process, the process by which ammonia is produced. So in this case, we have how many elements do we have here? We have iron, we have vanadium, mercury, and lead. One thing that we know is that in the Haber cycle, iron is used. So the option where there's iron is B, where we have iron in the Haber cycle and vanadium in the contact process. So therefore, the answer for question 9 is the option B. Question 10. Which of the arrangement below is suitable for collecting a soluble gas that is denser than air? The correct option there, that is denser than air and soluble gas as well, is option C. When you look at option C, we have calcium oxide there, and then a reaction takes place producing a gas, and that gas goes direct into the gas jar. Water is not involved in that case. Why? Because it is soluble. So when a gas is soluble, you don't have to use water. Then question 11. The relative formula mass of calcium hydrogen carbonate is, so for us to find the relative formula mass of calcium hydrogen carbonate, we need to write the formula for calcium hydrogen carbonate. So the formula is calcium hydrogen carbonate, like that. So that is the formula. So for us to find the relative formula mass, we list the elements that are there. Then we multiply the number of atoms by the molar mass. So calcium, we have calcium in that compound. We have hydrogen. We have carbon. we also have oxygen. How many atoms of calcium do we have? We have 1. How many atoms of hydrogen do we have? We have these 2. This 2 is for everything that is in the brackets here, but not for calcium. So 2 atoms for hydrogen. How many atoms of carbon? We have 2 atoms of carbon. How many atoms of oxygen? We have these 3. So 3 multiplied by 2 giving us 6. So 6 atoms of oxygen. So then we multiply the number of atoms by the mass number. Where do we get the mass number from? We get the mass number from the periodic table. So the mass number of calcium is 40. Mass number of hydrogen is 1. Mass number of carbon is 12. Mass number of oxygen is 16. When you multiply this, you get 40 here. There you are going to get 2. Here you are going to get 24. Then here you are going to get 96, if I'm not mistaken. That is 6 multiplied by 16. That will give us 96. Then we add 96 plus 24, then plus 2, plus 40. What do we get there? That is 162. 62. So 162 is option D, and that is our correct answer. Then we move on to question 12. Which of the following statements explains why magnesium, calcium, and barium are placed in group 2 of the periodic table? One thing that you should know about the periodic table is that when we look at the way elements are arranged on the periodic table, the periodic table itself consists of periods as well as groups. So an element is placed in a particular group depending on the number of electrons that are there in the outermost shell. And an element is placed in a particular period depending on the number of shells that element has. So explain why magnesium, calcium, and barium are placed in group 2 of the periodic table. Simple. Number of electrons in the outermost shell. So those number of electrons, since these are metals and they all have 2 electrons in the outermost shell, when they react with other elements, the non-metals, what is going to happen is that they will lose the electrons. So looking at the options which we have here, they all have 2 electrons in the outermost shell, correct? They form basic oxides that are soluble in water. Their outer electrons are 2 when they react with non-metals. They are lost when they react with non-metals. They form positively charged ions. So which option there is correct for question 12? They have 2 electrons in the outermost shell. It is the number of electrons in the outermost shell that determines how an element is supposed to be placed in a particular group. So the number of electrons are 2, and therefore they are going to be placed in group 2 of the periodic table. Then question 13. How many molecules are found in the 6.0 decimeter cubed of carbon dioxide at room temperature and pressure? So for us, from the question, from what we've been given according to the question, we can say, we can collect the data. We have the volume, which is equal to 6.0 decimeter cubed. But the question is asking us to find the number of molecules that are found in that volume. And then we've also been given the condition, which is room temperature and the pressure. So for us to do that, using the condition which is given there, we go to Avogadro's law. The Avogadro's law states that the volume of a gas is directly proportional to the number of moles of the gas molecules present if the pressure and the temperature are constant. And therefore, we use the formula number of moles is equal to volume over molar volume. Number of moles. Okay, then this is equal to N is equal to V over Vm, where N is equal to number of moles, the unit mole, then volume is equal to, V is equal to volume, units, centimeters cubed or decimeter cubed, then molar volume, Vm is equal to molar volume, which is the units mole per decimeter cubed or mole per centimeter cubed. So, since we already have the volume that is 6.0 decimeter cubed, we first of all find the number of moles. Over, we have Vm, which is the molar volume. Where do we get the molar volume from? From the condition given in the question, which is RTP. RTP, that is 1 mole of any gas at room temperature and pressure, occupies about 24 decimeter cubed or 24,000 centimeters cubed. If it is STP, it will occupy 22.4 decimeter cubed or 22,400 centimeters cubed. So, since the volume is already in decimeter cubed, you're also going to get the decimeter cubed for RTP, which is 24 decimeter cubed per mole. Then we divide. Decimeter cubed and decimeter cubed will cancel. That, when we divide that, what are we going to get? 6.0 divided by 24. This is going to give us 0.25 moles. So, N is equal to 0.25 moles. So, therefore, since we have N, which is equal to 0.25 moles, then we use the formula, which is number of moles is equal to X over Na. In this case, Na is the Avogadro's constant. And the Avogadro's constant is represented by the symbol Na. So, Na represents the Avogadro's constant. And this is equal to, usually equal to 6.02 times 10 to the power 23 particles. Then X is equal to number of particles. And these particles can either be ions or atoms, or they can be molecules. So, since we are looking for the number of molecules, so what we are going to do is we are going to find X. And therefore, we need to make X the subject of the formula. So, X will be equal to N multiplied by Na. N, we've already calculated N there, which is equal to 0.25 mole multiplied by the Avogadro's constant, which is equal to 6.02 times 10 to the power 23. This, when you multiply that, we are going to get 1.5 multiplied by 10 to the power 23. We look at the options which have been given there. Do we have the answer which is similar to what we've gotten here? So the only option which the option which is similar to our answer is option A. Option A is 7.5 times 10 to the power 23, and that is the correct answer. So the correct answer for question 13 is A. Thank you so much for listening, viewers. For now, we take a quick short break. See you on the other side as we get into details, section B of the revision lesson. Thank you.
Okay, let me know how it goes.
I will. I need to go now.
And don't forget to check up on your brothers.
Ziba mami, I will. I really need to go. Nisachedwa.
And also wish your dad a happy birthday.
Bye. Ish, my mom. She never stops talking, but I'm not complaining because I love our conversations. And MTN's 777 Just For You makes life and communication so much easier. Especially for a student like me, cause sinisebenza just yet. So, with 777 Just For You, I get special discounted data and voice bundles that allow me to do my schoolwork with ease and keep up with the latest trends online. I get to call my family and friends, plus there's also a gift folder. To cut the long story short, I talk more and browse longer. That's my mom. I better video call my dad and brother before class. MTN gives you so much more with 777 Just For You. Enjoy amazing day and night bundles, super fast 4G data bundles, Loko Nilaka, and more. Plus, you also get a special gift from us. Simply dial *777# and select an offer of your choice. Sekelela, we are on your side.
MTN.
Welcome back, viewers, and thank you so much for your time. Stay tuned as we continue revising 2019 School Certificate Chemistry Science Paper 2. So we go straight to the remaining question in section A, which is question 14. Which of the following is an alloy? We have rust, silver, bronze, and tungsten. When you look at rust, you can't define that as an alloy. Silver is an element. Tungsten is a metal, which is also an element. So the correct answer there is bronze. 15. Halogens are useful elements but also cause harm to the environment. Which of the following is a true danger of halogens? They, A, cause HIV and AIDS in human beings, which is not true. Deplete the ozone layer. C, are used to treat wounds. D, or release harmful radiation in the environment. The correct answer there is they deplete the ozone layer because of the chlorofluorocarbons which go into the ozone layer and depletes it. The best way, question 16, the best way of preventing spanners, pillars, and screwdrivers from rusting is A, artificial protection, B, tarring, C, oiling, D, galvanizing. 16, the correct answer is C, which is oiling. That is the best way of preventing them from rusting. 17, the gas that combines with the hemoglobin and reduces its capacity to carry oxygen in the body is, we know very well that hemoglobin is a molecule that is found in red blood cells, and this molecule is specialized in transporting oxygen around the body. But the carrying capacity of hemoglobin to carry oxygen can greatly be reduced when carbon monoxide is available. So the correct option there is carbon monoxide, not carbon dioxide, not nitrogen monoxide, and not nitrogen dioxide. So the correct option is D. Question 18. Which of the following substances is not a synthetic fiber? We have nylon, cotton, polyethylene, polyester. Those are the options. When you look at the options, nylon is a synthetic fiber, polyethylene is also a synthetic fiber. Polyester is also a synthetic fiber. So cotton is not a synthetic fiber, and therefore the answer for question 18 is B. The compound represented below is, in that compound we see that there's carbon, there's a double bond there. Each carbon has contributed 2 electrons to the bonding. So we have a double bond, carbon to carbon double bond. And then we have hydrogen on the other side of carbon, hydrogen on one other side of carbon, hydrogen and another hydrogen. So this compound is ethene. So ethene is the correct answer, which is option C. Question 20. What is the name of the compound below? This compound, when you look at it, it consists of a carboxylic acid and an alcohol as well. So the correct answer there is not ethanol, because that is not an alcohol. Ethanoic acid is not correct because that is not a carboxylic acid. Ethyl ethanoid, yes. Why? Because that is an ester, which is formed by a carboxylic acid as well as an alcohol. Methyl propanoid is an ester also, but not correct. Why? Because there are 2 atoms. There are 2 atoms of carbon from carboxylic acid, and there are also 2 atoms of carbon from alcohol. So it is formed by ethanoic acid and ethanol. So correct option is C. Section B. We'll just run through the questions so far so that we're able to finish this section fast. Write your answers in the spaces provided in the question papers. B1. Matter is made up of 3 basic units. State the 3 basic units of matter. The basic units of matter are atoms, ions, and molecules. Those are the correct answers. B. Give the basic unit of matter contained in common salt. Common salt, that is sodium chloride. Sodium chloride is made up of sodium ion and chloride ion. So the basic unit of matter contained in common salt are ions. Then noble gases like argon are made up of one of the basic unit particles. State the basic unit particles in noble gases. The basic unit is an atom. Noble gases usually are elements, and every elements are made up of atoms. B2. The table below shows the description of substances A, B, and C. Give the physical state of each of them. Substance A, B, C, description, state of matter. Particles occupy any space available. Then particles closely packed. Particles move randomly within the space of the substance. So for A, the answer is gas. B, it's solid. C, it's a liquid. Why? Because they move randomly within the space of a substance. Like if you put them in a container, they'll move in that space of the substance where you've put them. But the ones which move, occupy any space which is available, the state of matter is gas. How can substance C attain the structure of substance A? Substance C is a liquid. How can it attain the state of matter, which is gas? By heating a liquid. When you heat a liquid, the molecules will gain kinetic energy, which will cause them to move randomly and cover the spaces which are available. Substance B is said to be pure substance. Give characteristic which proves that B is a pure substance when heated. Substance B is a pure substance because it has a constant melting point. It melts at a constant temperature. Section B, question 3. The diagram below shows atom of sodium and chlorine. We have the diagram. A, state the type of bond that exists in the compound formed when the 2 elements combined, sodium and chlorine. Sodium is a metal, chlorine is a non-metal. The type of bond that exists between a metal and a non-metal is ionic bond or electrovalent bond. Draw the structure of the compound formed when sodium and chlorine combine. So the structure that will be formed there will be, this is sodium. The first shell accommodates 2 electrons. The next one will accommodate 1, 2, 3, 4, 5, 6, 7, 8. Sodium has an atomic number of 11, and therefore it has 11 electrons. So the outermost shell has 1 electron, which it will lose. And when it loses that electron, it becomes an ion with a positive charge, which is a cation. That atom which has been lost by sodium will be picked by chlorine. Chlorine has 17 as an atomic number, and it has 7 electrons in the outermost shell, and therefore it just needs 1 electron for it to be fully filled. So the structure of chlorine will be like this. This is chlorine, so we have that. Then the next shell will have that. Then the last shell, when we count the number of electrons in chlorine, they're supposed to be 17 plus the one which it gained from sodium. So because it has gained an electron, it is going to be an ion with a negative charge. So this compound, this is sodium ion, and that is chlorine ion. So there will be an attraction force that will exist between these 2 ions, which will lead to the formation of sodium chloride. Then state the chemical formula of sodium chloride. The chemical formula is sodium has a valence of 1. Why? Because it has only 1 electron in the outermost shell. So valence electron 1. Chlorine has a valence of 1 as well. Why? Because it has got 7 electrons in the outermost shell, and therefore for it to be stable, it has to gain 1 electron. So the valence of chlorine is 1. So when you interchange the valences, we're going to have sodium 1, chlorine 1, which will be equal to sodium chloride like that. So that will be the formula for sodium chloride. Explain in terms of bonding and structure why sodium chloride has the following properties. Why does sodium chloride has a high melting point? Because of strong electrostatic force of attraction that exists between the 2 ions. That's the more reason why it has a high melting point. Strong attraction force that exists between the 2 ions. Then explain why it is sodium ions has said sodium chloride has the following properties. High electrical conductivity when in molten state. It's because of the presence of the ions which are able to move freely. The presence of ions which are able to move freely is what makes it easy to conduct electricity in molten state. Question 4. Both barium carbonate and barium sulfate are insoluble in water. Choose a substance from the following list to fill in the blank space for this preparation of barium sulfate. Sulfuric acid, nitric acid, and lead-2 sulfate, magnesium sulfate. So barium carbonate, we are looking at preparation of barium sulfate. Barium sulfate has the formula SO4. So this is the salt which is insoluble. So when we are looking at the preparation of a salt, we need to find a substance that is going to provide us with the solution which will provide us with the cation for the salt, and a solution which will provide us with the anion for the salt. So we need to have a solution which will give us barium and another solution which will give us sulfate ions. So this is formed from barium 2+ plus sulfate 2-. Then this will give us barium sulfate. Okay, so barium carbonate is added in excess to a solution of dilute. So here we've not yet started the process of forming barium sulfate, but we need to have that solution which will provide us with the cation for the salt which are going to form, which is barium sulfate. And that, from the options which are given there, we have sulfuric acid, lead sulfate, magnesium sulfate, and nitric acid. The correct option there is nitric acid because it doesn't have sulfate. So the solution that does not have sulfate, when it combines with the barium carbonate, then it will provide us with the solution that will be able to provide the cation for the salt. The excess barium carbonate is filtered off to collect a suitable filtrate. The filtrate is then added to a solution of. Now we have that solution which is going to give us the cation for the salt, which is barium nitrate. So now that we have barium nitrate, we need to have another solution which is going to give us the anion for the salt. And looking at the options which are given there, the substances we can use are sulfuric acid and magnesium sulfate. So we can use sulfuric acid, or we can also use magnesium sulfate. So in there we can put sulfuric acid or magnesium sulfate to produce barium sulfate, which is then filtered off from the product mixture. B1. What type of reaction is used to prepare barium sulfate? The type of reaction which is used to prepare barium sulfate is the precipitation, or double displacement, or double decomposition. So those are the types of reaction. Construct a balanced equation for the reaction that produces barium sulfate in this particular case. So if we are using sulfuric acid, we'll say sulfuric acid plus barium nitrate. This is going to give us barium sulfate, which is the salt that we need, insoluble. So it is solid in its physical state, plus nitric acid, which is aqueous. Then if you are using magnesium sulfate, it will be plus barium nitrate. This will give us magnesium. This one is going to give us barium sulfate, solid, plus magnesium nitrate. So that is aqueous. This is aqueous. This is also aqueous state. So these are the two equations. So to balance our equations, what we can do here is we put a 2 there. By putting a 2 there, our equation is balanced. For the second one, let's check if our equation is balanced. Yes, the equation is balanced. So question 5, we go to question 5. Magnesium oxide reacts with dilute sulfuric acid as shown below. Magnesium oxide plus sulfuric acid will give us magnesium sulfate plus water. 600 grams of magnesium oxide was reacted with 980 grams of sulfuric acid. A, determine the limiting reagent in the reaction above. So for us to determine the limiting reagent in the reaction, we need to take the mole ratios. So we'll say magnesium oxide plus H2SO4. This will give us magnesium sulfate plus H2O. We check if our equation is balanced. Yes, the equation is balanced. When we take the mole ratios, it will be 1 to 1 to 1 to to 1. So mole ratio is 1 to 1. And when mole ratio is 1 to 1, that makes our job even easier. We just go straight and find the number of moles of the reactants which are there. So the reactants there are magnesium oxide and sulfuric acid. And we've been given the mass of each reactant that reacted in the reaction. So using the mass that we've been given there, we find the number of moles. So number of moles, we can say magnesium is X and sulfuric acid is Y. So number of moles of X, which is magnesium oxide, is equal to mass over molar mass. Mass of magnesium oxide from the question is 600 grams over, what is the molar mass? Magnesium oxide. Magnesium itself has a mass number of 24. Oxygen has a mass number of 16. Each one, we have one atom of each element in that compound. When you add that, we are going to get 40. So we divide this by 40 gram per mole. We are looking for the number of moles. So gram and gram will cancel. So when you divide 600 divided by 40, that is going to give us 1.5. So our answer here is 1.5 moles. Then we go to the next one. Number of moles of Y, that is H2SO4, is equal to mass over molar mass. Then our mass which we've been given for sulfuric acid is 980 grams over molar mass. We get the formula H2SO4. We list the elements contained in sulfuric acid HSO. Then this is equal to number of atoms 2 in hydrogen plus multiplied by the mass number, which is 1. Then how many atoms of sulfur? 1 multiplied by 32, which is the mass number. How many atoms of oxygen? 4 multiplied by 16, which is the mass number. Then this is going to give us 2. Here we are going to get 64. And here we will get 4 multiplied by 16, that is going to give us 4 multiplied by 16 will give us 64. Here we have 32. Okay, so 64 plus 32 plus 1, not 1 but 2, it will give us 98. So 98 gram per mole. Then you divide that, so that will be 980 divided by 98 will get 10. So when you look at the limiting reagent in this case is that reactant that is in short supply. And because it is in short supply, it ends fast even when the other reactant is still available. So it determines how far the reaction is supposed to proceed. And therefore, looking at the number of moles that we have, for sulfuric acid, the number of moles that took part in the reaction is 10. Then for magnesium oxide is 1.5. And therefore, the limiting reagent in this case, just a minute, 600 divided by 40, it's 15, not 1.5. So the smallest number of moles is the limiting reagent. So therefore, Y, which is sulfuric acid, with a small number of moles, is the limiting reagent. We move on to the next question. Calculate the mass of magnesium sulfate that was obtained at the end of the reaction. So when we are looking at the mass of magnesium sulfate, we need to compare with the mass of one of the reactants. So the reactant that we are going to pick here is the reactant which was in short supply, which was the limiting reagent. So that is the mass that we are going to get. And that one is sulfuric acid. So from the equation, we are going to say magnesium oxide plus H2SO4. This will give us magnesium sulfate plus H2O. We have a balanced equation. So the next step is we pick out what we've been asked from the question and then we start solving. What we've been asked here is to calculate the mass of magnesium sulfate. So we are going to say magnesium sulfate. 2, we get the limiting reagent because we have got two reactants here, magnesium oxide and the sulfuric acid. We are not going to use magnesium oxide. Why? Because magnesium oxide was the excess reagent. It remained even when the reaction had come to completion. So we'll say H2SO4 being the limiting reagent because it is the one which determines how much product is supposed to be formed in the reaction. Then we get the molar mass of magnesium sulfate here. So molar mass will say magnesium sulfate So we have magnesium, 1 atom, which is equivalent to 24. Then we have sulfur, which is the same, which has the mass number of 32 from the periodic table. Oxygen, the mass number of oxygen is 16 multiplied by 4. So 16 multiplied by 4 will give us 64. So 64. Then we add. When we add this, we are going to have 0 there, 120. So 64 plus 32 plus 24. We'll have 120, yes. So we'll say 120. Remember, we already calculated the molar mass for sulfuric acid, which is this one here. This one. So we just transfer that molar mass and we do this. So say 98 grams will give us 120 grams. Now, since it was the limiting reagent, what mass of sulfuric acid was used? It was 980 grams. This is going to give us what? X. Then we make X the subject of the formula. So X is equal to 980 grams multiplied by 120 grams divided by 98 grams. Then that is going to give us 980 multiplied by 120 divided by 98. This is going to give us 1,200. So 1,200 grams. Why? Because we are looking for the mass. Then C. 1,180 grams of magnesium sulfate was obtained at the end of the reaction. Calculate the percentage yield. So percentage yield is calculated using this formula. Percentage yield is equal to actual yield over theoretical yield. Okay, so from the question, our actual yield, when you look at the question, which is C, 1,080 grams of magnesium sulfate was obtained at the end of the reaction. So after the reaction had taken place, what was obtained was 1,080 grams. So that was the actual yield. So 1,080 grams, we divide that by the theoretical yield. The theoretical yield is the one that is calculated from the equation using more concept, the one that is expected given the figures. Then that already we've calculated is 1,200 grams. So multiplied by 100%. So here you multiply by 100%. So this, when you divide, it's going to give us 1,080 divided by 1,200. This will give us 109 multiplied by 100%. This will give us 90%. So our percentage yield was 90%. Question 6. The graph below shows the collection of oxygen gas during an experiment over 60 seconds from 1 molarity hydrogen peroxide. We have that graph. A1. Describe how the rate of reaction changes with time. So here we can say there was an increase in the first 20 seconds. Thereafter, it decreased with time. So the reaction increased in the first 20 seconds. There, from there, it decreased with time. Then question 2. At what time does the reaction come to an end? When you look at the graph, the reaction came to an end at about 45 seconds. That's when the reaction stopped. When the graph became constant, that's when the reaction stopped. Give a reason for your answer. Because the graph flattened, that's the reason. You found that it had gone, like for instance, it started from 0, then it went like that. So at a point when it became constant, it flattened, that is the point when the reaction came to an end. The beginning of the flattening curve is when the reaction stopped. How much volume of the gas was produced at the time the reaction came to an end? The volume was 60 cubed centimeters. Thank you so much, viewers. We've come to the end of our revision lesson. Because of time, we are unable to get into section C, but I hope that what we've obtained here will be able to help you prepare for your exam as you are at home. Thank you so much and bye.
Tiende pamoja ni mtima umo. 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 Tiende pamoja ni